Hey guys, it's Miss Adams, and we are going to be looking at the Unit 5 test review. So this is our exponential functions and geometric sequences. So let's start with just graphing an exponential function. So remember, our parent function of an exponential function is y equals a times b to the x minus h power plus k. And that a value is our initial value, b is our change factor, the h value is our horizontal shift, and k is our horizontal asymptote. So it says complete the table and graph each exponential function. So in order to complete the table, we're going to need to use a calculator. And in your calculator, you're going to hit the table button, then open parentheses, fraction 1/2, close parentheses, raise it, so use that little caret hat button, to the x power, and then we're going to hit right arrow twice and add 3. From there, I'm going to fill in my table. It has me starting at -2, and at the value of -2, our y value is 7. Value of -1, our y value is 5. At 0, our y value is 4. And at 1, our y value is 7/2, which is the same thing as 3.5. So I'm now going to graph this exponential function. So at -2, I've got the value of 7. -1, I have the value of 5. 0, 4. And 1, 3.5. If I'm looking at this, I know that I have a horizontal asymptote at y equals 3. So I'm going to put a horizontal line here at y equals 3. And I'm going to connect my dots. Looking at this, my change factor, so my b value, is less than 1. So therefore, this is a decay function, and we can see that as x increases, my y values are decreasing. Because our horizontal asymptote is above the x-axis, we are not going to have an x-intercept, so we're going to put none for our x-intercept. And our y-intercept is where x is 0, so we have a y-intercept at 0, 4. The domain for this function is going to be -infinity to +infinity. And our range is going to start at our horizontal asymptote, which is 3, and increase to +infinity. Because this is a decay function, it's never going to increase, and it will always decrease from x values of -infinity to x values of +infinity. Now let's look at our end behavior. When x is going to -infinity, so that's on the left-hand side of my graph, my y value is going all the way up to +infinity. Likewise, on the right-hand side of my graph, when x is increasing to +infinity, my y value is going to approach 3, but it will never touch 3. We're going to do the same thing with this second function. I've given you g of x is equal to 0.5 times 3 to the x power. So go back to that table function and now enter in 0.5 times 3 raised to the x power. When x is -1, it's giving me a y value at 0.16 repeating. When x is 0, y is 0.5. When x is 1, y is 1.5. And when x is 2, y is 4.5. So I'm going to graph those values, but let's look at our horizontal asymptote first. Since I don't have anything added, I can assume that it's +0. So my asymptote is going to be at that x-axis, so where y equals 0. This is going to be a growth function because my b value is greater than 1. So this is a growth function. If I graph this at -1, I'm almost at 0, but not quite there. 0 is going to be 0.5, 1 is 1.5, and 2 is all the way up here at 4.5. So this is increasing. So as x increases, my y value is increasing. Because my horizontal asymptote is at my x-axis, I will not have an x-intercept. My y-intercept is anywhere where my x value is 0, so that's going to be at 0, 0.5. My domain doesn't change, so this is going to be -infinity to +infinity. The lowest y value I can have now is 0. That's where my horizontal asymptote's at, and it's going to go all the way to +infinity. As x increases, y increases, so my increase for this is from -infinity to +infinity, and this will never decrease. If I'm looking at this, as x goes to -infinity, my y value is going to approach 0, but it won't ever touch 0. And as x goes to positive infinity, y is also going to go to positive infinity because this is an increasing function. All right, if I'm identifying the equations for the graph on number 3, this is a multiple choice question. I know that I am one above where y equals 0, so I know I'm going to have a horizontal shift up by 1, and this is a growth function. The only one that has a horizontal shift up 1, because notice my horizontal asymptote is now at y equals 1, is C. For number 4, I'm looking for a horizontal asymptote where y equals 0, so I can automatically eliminate B and C. And this is a decay function, so the correct solution is A for number 4. All right, guys.